we have been looking at examples in each of the feedback amplifier types. So we started with voltage series feedback. In voltage series feedback, we have three practical examples. First one is common collector amplifier, or it is called as emitter follower. Then we have in BJT you have a common collector amplifier. In FET you call it as common source amplifier or source follower, common drain amplifier or source follower, and we have voltage series feedback pair. So for all these circuits, we are going to analyze the circuit and we are going to find all the parameters relating to that amplifier. So in voltage series feedback, the second one what we are seeing is this one. It is called as common drain amplifier, or it is called as source follower. Okay, it is called as FET source follower. So the diagram is shown. It is visible to you, I think. So common drain amplifier. So drain will be connected to VDD. You will not be grounding the drain. You will be connecting drain to VDD because this VDD is required for the operation of FET. Input is given to gate and output is taken from source. I cannot ground the source. When I ground the source, it will also become a common source amplifier. So I'll be connecting a resistance at the source and I'll be taking output across the source resistance RS. Analyzing a FET is very simple because the H parameter equivalent diagram or the low frequency equivalent diagram is very simple. Input side, nothing will come because input impedance of FET is very high. So input side will be completely open. Output side you will be having GM, a current source followed by resistance. That's all. So analyzing FET is very simple when compared to being BJT. We have the parameter called HIE, correct? And that HIE is a very small value. We cannot neglect that HIE. But in FET, the resistance at the gate is very high because gate is insulated. An insulator will not conduct. So the current is zero. So resistance is going to be very large. So when you draw the low frequency equivalent circuit of FET, the input side is going to be open and output side will have the corresponding current source and the resistant values. So we are going to see that. So this is the basic circuit diagram of your common drain amplifier or source follower, and this is going to be acting like a feedback. This resistance RS is going to act like a feedback resistor because the voltage across RS is again fed back to the input. It is added with the input in opposite sense. Okay, so the feedback signal is the voltage across RS and it is added along with the input signal Vs at the gate side. So this configuration corresponds to voltage series feedback method topology because the output from RS is taken and it is directly applied with the input signal in series. So it is called as voltage series feedback network. So analysis step is very simple. So you replace the diagram with an equivalent low frequency low frequency equivalent circuit for FET, and you measure the parameters what you want to do. So for analyzing, the first thing you will be short circuiting the voltage. So the drain will be connected to ground and source will be connected to RS to ground, and the input will be given to gate. So this RS will be present across source and drain. So if you connect this drain, it will come somewhere here, right? So I can say this RS is present between D and R. Across RS, I'm going to measure V out, and across RS, I'm going to measure VF also. Okay, so the output for finding the output circuit, you have to make the input current 0. So if you make the input current 0, on this only the drain current will be flowing in this direction. Okay, so this RS is present only at the output side. So input side RS will not come. For drawing the input circuit, you have to take output voltage 0. When you make output voltage 0, this RS will become short circuit. So this Vs will be appearing directly across gate and source. So input side you will not be getting RS, you will be getting RS only at the output side. So see here, that is what is given. Once you find the input and output circuit, what components are going to be present, you are going to replace the FET by the low frequency model. In BJT exclusively you call it as a H parameter model. In FET you don't call it as H parameter model, you call it as low frequency equivalent circuit. And same as your common collector amplifier, beta value is 1 because VF and V0 are going to be same.